Hello, everybody. Once again, I am here with you for the new session that is waves and oscillation. And in the previous session, we have seen that what exactly the energy of a plane progressive wave and what exactly the amount of kinetic energy and the potential energy is to be there as far as the propagation of the energy is to be there. Today we will see something again related with the waves, but also a new type of the wave that is called to be as a string is to be there. How this string is going to be form a wave motion, and what exactly the relationship for that we will see in detail. So as far as first we have to understand what is mean by to be as in your string is to be there. The string is just like this, two ends are going to be a fixed. There is any row or anything you can say as a rubber, the two ends are going to be fixed points are to be there, and you are disturbing it, it will gives you generates the wave motion. Likewise in this case, as the two ends are going to be fixed, when that is the mean position of these particles, and every point is taken to be as an particle here on this rope or the rubber is to be there. That is again the how what is wave motion. We have seen that disturbance created in this case, that will create a vibration, that is repeated and periodic vibrations are going to be generated and wave motion is going to be generated. So this is all about what the strings vibrations are to be there. Now in this case, when I am, this is what the total length, that is PQ, here it is shown in the your diagram also, that whatever the rubber is to be there, that is this is the way length, total length, that is PQ is to be there. Sorry. So in this case again, if I wants to find out the another part, how much amount of the element is to be plucked out, that is to be the AB is to be the area where it is to be plucked out, that here it is shown in this case, that amount of plucking out disturbing this particular area is nothing but to be what amount of I am plucking it out, that is to be the case. And here it is to be given that AB is to be there. Now in this case again, the whatever the length that plucked out area, it is nothing but to be dx or the del x you can say. So when I am drawing normal, or when it is the automatically this will not happen, I have to create a tension, then it will be giving me, when I am plucking it out, that means I am giving some tension, then the waves are going to be generated in that case. This tension, when I am giving at the time when I am applying this displacement, that time the pressure or the force is to be for some sort of giving me tension at this point, and that tension is to find out as the particularly if I draw two tangents at the point A and the another one is at the point B, that will give me the one angle that is called to be as in theta, and the another angle which is made at the point B is nothing but to be a theta minus d theta is to be there. Now why this angle is going to be changed, as good as the A point is to be there, this angle is going to be theta, one angle made that is to be theta. But as far as the B position is to be there, which is at a distance of del x, that element length is to be as in del x is to be there, that is small amount of the is to be there, and that's why this del theta is going to be in that case minus in that particularly angle is going to be concerned. So this is what the case where this total the string arrangement or the what exactly this your tangents are drawn at these cases are to be there. Now in this case, when I am doing this thing, that is the tension is going to be applied, the tension working in the downward and the upward, that we will see in detail. So when the this plucking this area as a del x, then that time the whatever be the downward tension at A is going to be calculated. Now here if you look at this case at this point A, if you look at this particular case where this makes you nothing but to be right angle triangle, and that will give you nothing but to be angle as in theta. When I am calculating this particularly tension at A, then it is nothing but to be T sine of theta. T, whatever the tension, that means what amount of the pressure or tension I am applying, that plucking this area for maximum distance, that it will have the maximum tension. If for the smaller distance, it will be T will be the lesser one. So according to that, the tension is to be there. So the T into this angle made by, that is to be as an your sine theta is to be the case. But as far as this case is concerned to be as an angle, smaller angle, when this theta is going to be the smaller, definitely this sine theta will be coming to be as a your tan theta is to be there. So in this case, whatever be the your sine of theta value, for the smaller value of the sine theta, the whatever be the similar value you will get for the tan of theta. So I can replace this sine theta for as an your tan theta, because it having the similar relationship or similar values for the both the things, for the smaller of theta angle is to be there. And in this case, the component of the tension, or the downward component tension at B at A is to be there. It is nothing but to be T into tan of theta. So that's why this at A position, whatever be the your tension is to be there, it will be coming to as an T tan of theta is to be there. But tan theta is nothing but to be the slope. As far as this theta is to be there, in if I am finding out tan theta, it is nothing but to be a tan theta is to be sine upon cos is to be there, sine theta upon cos theta is to be there. So in that case, this is nothing but to be a slope, becomes, it becomes to be as a slope of the particular displacement is to be there. So that's why the dy is nothing but to be displacement. If you look at here the case where it is to be shown to be here to be as an, this is somehow little bit, I have to move it. So here you will see, this is what the case where this tan theta is nothing but to be your value becoming to be as an dy by dx is to be there. So if you calculate this tan theta also, you will get this dy. Dy is nothing but to be the in front of whatever be the line. This displacement is the, that is to be related with the dy, and dx is nothing but to be the position according to that. So this is what the tan theta is to be there. So in that case, if I am replacing this value of the tan theta again, so the relationship I will get little bit t dy by dx, instead of tan theta I will write to be as in there dy by dx is to be there. So that much of amount is to be there as far as the your downward tension is concerned. So this equation number 1 will be nothing but to be capital T, whatever amount of tension I have given, according to that the slope of the displacement is to be there. So that will be the downward tension working at a point A is to be there. So if I want to find out rate of change of this slope, then again I have to differentiate this value with respect to x is to be there. So slope, the values to be related with the position and the distance. That's why if the length is nothing but to be as an your x total length, we have considered as far as this total PQ relation value. This total length of the PQ is nothing but to be taken as the x. So in that case, whatever be the rate of change of slope with respect to the length, if I want to find out, I have to ddx. So ddx of dy by dx, that will become to be as an d2y by your dx square is to be there. So this is what the slope, but this slope is going to be changed with the displacement del x, means that is to be the what amount of, that is the d2y by dx square is the slope, whatever be the rate of change of slope is to be there, but what amount of I am plucking out, that also matters. So that's why what amount of the area I am plucking out, that is the sorry the length is going to be plucking out, that also matters. If I am small, it will become different vibration. If I am taking larger area, that will become to be a different vibrations are to be there. So according to that, how much area I am taking here, or sorry, how much length I am plucking out, that also matters. And that's why change in the slope for the distance dx is nothing but to be again given here with the d2y by dx square into del x is to be there. So this is what the change in the slope at a distance dx is to be there. So at the position or slope at the point B, if I wants to find out, in the same fashion the tangent is drawn from the your point B is to be there. So at that point, whatever be the angle made here, already I have shown in the figure, that is to be the angle made at this stage is nothing but to be theta minus d del theta or d theta is to be there. So in this case, if you look at the whatever be the at the point A, displacement slope is going to be there, I am calculating, it was to be dy by dx is to be there. But as far as the tan of theta, we have taken this value is to be there. So related to that, so again if I want to find out the slope at the point B, then I have to taken into account this angle, that is theta minus del theta is to be there. So tan of del theta minus tan of theta minus del theta I have to taken into account, and no doubt this is why again the dy and related to this, and again dx is to be there. So if I put these values, or if I want to find out the slope at the point B is to be there, no doubt the value will be here, it is again shown here to be as an t theta minus d theta or del theta is to be there. No doubt theta value you are aware about that, the theta is nothing tan of theta, yeah, minus tan of del theta is to be there. So tan theta we know, that is dy by dx, I already told you. And as far as the del theta is to be there, that is becoming to be as an d2y differentiation, double differentiation, that gives us d2y by dx square is to be there. So this is what the tan theta minus d theta value is going to be calculated into dx. For this, what the value is to be there, the plucking area is to be there. Now as the downward force is working, the upward direction force is also tension is also working. So when I am plucking this area, the downward tension is also working, and when I am left this plucking, the area the length is plucked area, that is AB, then similarly it goes back and again comes up, and the waves will be generated. That means it is not stop. म्हणजे काय की जेव्हा मी प्लग करायला ह्या एरियाला, त्यावेळेस तो वर जाते, त्यावेळेस मला काहीतरी टेन्शन डाऊनवर्डला काम करते. पण जेव्हा मी हा सोडून देतोय, त्यावेळेस काय होते की तो डाऊनवर्डला जातोय आणि पुन्हा अपवर्डला येते. असं होत नाही की तो अपवर्डलाच थांबेल एक व्हायब्रेशन होऊन, आणि तसं नाही. जेव्हा मी याला प्लग करून सोडून द्यायलो, तेव्हा तो काय केला, डाऊनवर्डला चालला, पुन्हा अपवर्ड यायला, पुन्हा मीन पोझिशन यायला, पुन्हा अपवर्ड चालला, पुन्हा मीन यायला, पुन्हा डाऊनवर्ड चालला. म्हणजे ज्याप्रमाणे डाऊनवर्ड टेन्शन काम करते, त्याच पद्धतीने अपवर्ड टेन्शन सुद्धा काम करायला. मग ते अपवर्ड टेन्शन ॲट पॉईंट बी किती आहे, दॅट इज व्हॉट द अपवर्ड कंपोनंट टेन्शन ॲट पॉईंट बी, दॅट वी आर गोइंग टू कॅल्क्युलेट, अँड दॅट इज नथिंग बट टू बी अकॉर्डिंग टू दॅट मी किती प्रमाणात ह्याला टेन्शन देणार आहे, अपवर्ड म्हणजे ह्या ठिकाणी डाऊनवर्डला जसं काम करणार आहे, त्या पद्धतीने अपवर्ड जितक्या मी जास्त वर ह्याला प्लग करत, तेवढा जास्त तो वर येईल. दॅट इज कम बॅक विल इन द सेम फॅशन. So in the same way, the T is going to be the what amount of tension is working, according to that the tension will be becoming to be as an upward. डाऊनवर्ड डायरेक्शन ज्या प्रमाणात टेन्शन काम करेल, त्याच प्रमाणात अपवर्डमध्ये पण तेवढंच असेल. सो दॅट इज बट द रिलेशनशिप इज टू बी डिफरंट ॲज फार ॲज द अँगल इज देअर. T sin theta minus del theta is to be there. This is what the upward direction at the point B is to be there. Whatever be the upward direction tension is working, it is nothing but to be at the point B, is that at point B we are calculating. So it is nothing but to be T sin theta minus del theta is to be there. So in this case again we are aware about that, if the suppose the theta is going to be small, then sin theta minus del theta is equal to tan theta minus del theta is to be there. So this is what the similar case is to be there, and values are going to be similar for the sin theta and the tan theta. For the smaller value of the theta is to be there, as the theta is small, theta जर खूप small असेल, the sin theta ची value आणि tan theta ची value is going to be the similar one. So that's why I can put this sin theta minus del theta is equal to tan theta minus del theta is to be there. So the whatever be the upward direction tension, it will become to be as an T tan T capital T into tan of theta minus del theta is to be there. So this is what the upward direction tension is to be there working. आता आपण दोन्ही पद्धतीने बघितलं. एक काय बघितलं की ॲट ए पॉईंटला डाऊनवर्ड डायरेक्शनला टेन्शन काय काम करायले, आणि बी पॉईंटला अपवर्ड डायरेक्शनमध्ये टेन्शन काय काम करायले. पण ह्यामुळेच काय व्हायले की ते वेव्स आर गोइंग टू बी जनरेटेड अपवर्ड डायरेक्शन अँड डाऊनवर्ड डायरेक्शन. पण ह्या ठिकाणी बघा, आता जी काही स्ट्रिंग आहे तुमची, जेव्हा मी इथं प्लग करून सोडत असतो त्यावेळेस त्याच्या डाऊनवर्ड डायरेक्शनमध्ये टेन्शन काम करते. जेव्हा सोडून दिलं तेव्हा ती डाऊनला जाऊन थांबत नाही, तर ती पुन्हा अपवर्ड येते. मग दॅट इज अपवर्ड डायरेक्शन इज टू बी देअर. सो इन दिस केस व्हॉट इज द रिझल्टंट डाऊनवर्ड, पण ती पुन्हा खाली जाते. सो दॅट इज व्हॉट द रिझल्टंट डाऊनवर्ड टेन्शन आय हॅव टू कॅल्क्युलेट. सो नो डाऊट व्हॉट एव्हर बी दी युअर पॉईंट ए पोझिशन जवळचं जे काही तुमचं टेन्शन आहे, मायनस पॉईंट बी जवळचं अपवर्डचा येणारं टेन्शन, दॅट इज नथिंग बट टू बी द गिव्हिंग मी the value that is to be called to be as in your part resultant downward tension is to be there. That is from this way I can say that it is T into dy by dx minus d2y by dx square into del x is to be there. So this is what the part sorry, this is only for the your value for the t is to be taken. हे फक्त इक्वेशन नंबर 2 आहे. हे फक्त पार्ट आहे तुमचा डाऊनवर्ड सॉरी अपवर्ड डायरेक्शनचं जे काही टेन्शन आहे ते इथं इक्वेशन नंबर 2 मध्ये दिलेलं आहे. सो दिस इज टी इंटू dy by dx minus d2y by dx square del x is to be there. This is equation number 2 for the upward direction at the tension at the point where it is to be called to be as an here basically part where the downward tension and the upward tensions are to be there. So both the things are here, that is upward tension and the downward tension. So resultant force, that is from the equation 1 and 2 I can calculate. That is what the force F is equal to T into dy by dx minus T into dy by dx minus d2y by dx square del x is to be there. म्हणजे इक्वेशन 1 मधून इक्वेशन 2 जर मायनस केलं तर मला रिझल्टंट जे काही टेन्शन आहे ते मला मिळते आणि ते मी नोटिफाय कशाने करायलो, एफनी नोटिफाय करायलो. आणि म्हणून फर्स्ट इक्वेशन बघा आपलं टी इंटू डी वाय बाय डी एक्स आहे, त्याच्यामधून मी अपवर्ड डायरेक्शनचं टेन्शन दॅट इज टी इंटू डी वाय बाय डी एक्स मायनस डी टू वाय बाय डी एक्स स्क्वेअर डेल एक्स इज गोइंग टू बी मायनस. सो रिझल्टंट आता जर बघा इथं पाहताल तर इथं टी इंटू डी वाय बाय डी एक्स आहे मायनस इथं टी इंटू आहे. टी इंटू म्हणजे पुन्हा इथं काय येणार आहे टी इंटू डी वाय बाय डी एक्स एक व्हॅल्यू येणार आहे आणि मायनस मायनस प्लस पुन्हा काय येणार आहे टी इंटू डी टू वाय बाय डी एक्स स्क्वेअर डेल एक्स इज टू बी देअर. सो इथं काय होणार आहे टी इंटू डी वाय बाय डी एक्स मायनस टी इंटू डी वाय बाय डी एक्स ही व्हॅल्यू काय होणार आहे 0 होऊन जाणार आहे. एक प्लस आहे आणि एक मायनस आहे. मग उरला कोण हे मायनस मायनस झालेला प्लस म्हणजे काय उरलं की डी टू वाय बाय डी एक्स स्क्वेअर इंटू डेल एक्स आणि टी ऑलरेडी ॲज इट इज जो आहे तो आहेच. म्हणजे मला रिझल्टंट जे काही टेन्शन मिळणार आहे ते किती असणार आहे दॅट इज एफ इज इक्वल टू कॅपिटल टी इंटू डी टू वाय बाय डी एक्स स्क्वेअर into del x is to be there. This is equation number 3 which is resultant tension working at that plunked area is to be there. So हे जे काय आहे resultant तुमचा force tension is working at that stage. Now again if I want to see in a different fashion the tension is to be calculation, in that case I have to taken into account that is m be the length of the string per unit per unit length, string length, m be the mass for the string of the string at per unit length is to be there. म्हणजे काय की जर समजा मी आता ही स्ट्रिंग जी आहे ह्या स्ट्रिंगचं मला एक पर्टिक्युलरली मी आता जेवढा एरिया प्लंक आउट करायलो त्याचं मास मला मी कन्सिडर केलं किंवा पर युनिट एरिया. म्हणजे जर समजा आता मी साखळी घेतली आणि एक अशा रेंजमध्ये साखळी घेतली की त्याची 1 फूट लांबीची जी काही आहे सपोज दिस एक फूट लांबीची सपोज ही 1 फूट आहे आणि 1 फूट लांबीची जी काही तुमची साखळी आहे तिचं वजन समजा 1 किलो आहे आणि मी सारखीच साखळी 10 फूट लांबीची घेतली तर तिचं वजन किती होईल नो डाऊट 10 किलो होऊन जाईल बिकॉज इट इज मल्टिपल ऑफ 1 kg इज टू बी देअर. आता हे झालं 1 kg, हे झालं पर युनिट लेंथ. म्हणजे त्या साखळीचं वजन कसं झालं एका फुटाला 1 किलो म्हणजे 10 फुटाला 10 किलो. मग तसंच मी जर समजा 100 फूट लांब साखळी घेतली तर तिचं वजन होईल 100 किलो. इन द सेम वे आता मी इथं काय कन्सिडर करायलो एम बी द मास. म्हणजे एम इज टेकन ॲज ए नोटिफिकेशन व्हेरिएबल इज टेकन दॅट एम इज मास ऑफ द स्ट्रिंग पर युनिट लेंथ. म्हणजे पर युनिट लेंथ मास काय त्या स्ट्रिंगचं दॅट इज एम इज टू बी देअर. मग जर समजा पर युनिट लेंथ जसं मी म्हणलं होतं की 1 फूट लांबीची साखळीचं वजन 1 किलो आहे तर मी आता जर समजा हेच 10 फूट लांबीची साखळी जर मोजतो वजन त्याचं म्हणलं तर काय होणार आहे 1 kg इंटू 10. इन द सेम फॅशन म्हणजे इथं एम जो आहे तो पर युनिट लेंथ इथं कन्सिडर व्हायला. म्हणजे आपल्या साखळीमध्ये एम इज इक्वल टू हाऊ मच 1 kg. इथं सेम केसमध्ये जर समजा मी कन्सिडर करायलो एम बी द मास पर युनिट लेंथ. सो इन दॅट केस इफ आय वॉन्ट टू फाइंड आउट जेवढा मी एरिया प्लंक आउट करायलो ए बी एवढा लेंथ, त्याची लेंथ किती आहे डेल एक्स. आधीच म्हणलं की स्मॉल अमाऊंट टोटल लेंथ एक्स आहे तर स्मॉल अमाऊंट डेल एक्स त्याची. मग मला जर समजा जेवढा एरिया प्लंक आउट करायलो मी त्याचं वजन जर काढायचं असेल तर काय करावं लागेल, नो डाऊट एम इंटू डेल एक्स इज टू बी देअर. वाय इट इज टू बी देअर, कारण मी जसं म्हणलं की एका किलोचं वजन एक फुटाचं साखळीचं वजन 1 kg, तिथं एम इज टेकन ॲज ए मास पर युनिट लेंथ ऑफ द स्ट्रिंग. सो हाऊ मच अमाऊंट ऑफ द लेंथ इज टू बी देअर, डेल एक्स अमाऊंट ऑफ लेंथ. किती एरिया केला मी, डेल एक्स एवढा लेंथला मी प्लंक आउट केलं. मग एम बी द मास पर युनिट लेंथ, दॅट इज वाय एम इंटू डेल एक्स. म्हणजे मला काय मिळणार आहे, कम्प्लीट डेल एक्स एवढ्या लेंथ जी आहे त्याची, जेवढा मी एरिया प्लंक आउट करायलो त्या प्लंक आउट केलेल्या लेंथचं मला टोटल मास मिळाले. मग ते किती होणार आहे, मास ऑफ द एलिमेंट विल बी एम इंटू डेल एक्स इट विल बी देअर. सो हिअर इट इज हाऊ इट कम्स. आता इन जनरल ॲक्सलरेशन इज द जे काय आहे ॲक्सलरेशन इन द डायरेक्शन ऑफ द वाय. नो डाऊट पार्टिकल आपण हे जी पोझिशन ऑफ द पार्टिकल स्टेडी पार्टिकलची आहे ती अलॉंग द एक्स आहे. पण मी जेव्हा डिस्टर्बन्स क्रिएट करायलो तो डिस्टर्बन्स कोणत्या अँगलला करायलो, अलॉंग द वाय डायरेक्शन करायलो. आणि म्हणून जी काही स्ट्रिंगमुळे वेव्ह इथं जनरेट होणार आहे ती कोणती जनरेट होणार आहे, दॅट इज द युअर basically transverse wave. Because what is transverse wave, in the types we have seen in characteristics we have seen in detail, that transverse waves are nothing but to be when the vibration of the particles are perpendicular to the direction of the propagation of the wave is to be there. In that case we can say the whatever be the wave is going to be generated, that is the transverse wave is to be there. So as far as the acceleration in that direction, आता accelerationचं पार्ट पुन्हा काय की velocity with respect to time is to be, rate of change of velocity with respect to time is to be there. So in that case y direction मध्ये जर समजा dy y जर समजा डिस्प्लेसमेंट असेल तर dy by dt आपण मागे पण बघितलं की dy by dt is nothing but to be your velocity. आणि acceleration म्हणजे काय, ddt of dy by dt. So in that case if I am doing this case for the acceleration for the displacement y, it will become to be as an d2y by dt square is to be there. म्हणजे y ला डबल डिफरन्शिएट विथ रिस्पेक्ट टू टाइम इन सिंपल केस. सो दॅट विल गिव्ह मी ॲक्सलरेशन इन द y डायरेक्शन of the particle is to be there. So it is nothing but to be d2y by dt square is to be there. But in general again we are also aware about that force is nothing but to be mass into acceleration. हे जर अवघड वाटत असेल तर 12th पर्यंत आपल्याला जसं f इज इक्वल टू एम ए. एम ए काय, एम इज नथिंग बट टू बी युअर मास, a is what, a is nothing but to be your acceleration. So f is the force. The force is defined in the fashion of mass into acceleration is to be there. So what is the mass we calculated for that element, that is m into del x is to be there. And what is the acceleration, it is d2y by dt square is to be there. So if force I wants to write in this fashion, जर समजा मला ह्या स्ट्रिंगच्या बाबतीमध्ये जर मला फोर्स इम्प्लिमेंट करायचा असेल तर दॅट इज नथिंग बट टू बी f is equal to m into del x into d2y by dt square is to be there. So this is your equation number 4, which is also representing the force acting on the string is to be there. So this is what the equation number 4. Now what is the equation number 3 and equation number 4 are there. Equation number 3 सुद्धा काय करायले, टेन्शनच्या फॉर्मॅटमध्ये मी किती प्रमाणात ह्याला प्लंक आउट करायलो त्यानुसार टेन्शन तिथं जनरेट व्हायले. आणि इथं काय केलं मी, फोर्स, त्याचं जे काही फोर्स कॅल्क्युलेट केलं अलॉंग विथ द युअर स्ट्रिंग इज टू बी देअर. सो बोथ द केसेस आर गोइंग टू बी सिमिलर. म्हणजे ते टेन्शन मी ज्या प्रमाणामध्ये ह्याच्यावर प्लंक करणार आहे, जेवढं जितकं जास्त तेवढ्या प्रमाणात टेन्शन इथं जनरेट होणार आहे आणि तेवढं जास्त फोर्समध्ये हे व्हायब्रेशन त्याचं होणार आहे. सो बोथ वे मी काय केलेलं आहे, फोर्स आय हॅव गोइंग टू बी कॅल्क्युलेटेड. सो इक्वेशन 3 जर समजा आणि इक्वेशन 4 जर समजा मी कम्पेअर केले तर दॅट विल मी दे समजा बघितले तर इट इज वन टाईप ऑफ द सिमिलर केस आय एम सेम थिंग आय एम रिप्रेझेंटिंग. So this is what the equation from equation 3rd and equation number 4th. We can say that whatever the tension, resultant tension you calculated and the force you have we have calculated, that is going to be the similar one. So in this case, if you look at this left hand side value is nothing but to be here. ह्या लेफ्ट हँड साईडला जर बघता आलं तर ही व्हॅल्यू आहे एम इंटू डेल एक्स इंटू डी वाय बाय डी टी स्क्वेअर. It is from the your axle from the your calculated force is to be there. And if you look at this t into d2y by dx square into del x, this is what the according to the tension given, किती टेन्शन दिलं त्यानुसार vibrations are to be there. So both the things are equal. So from the equation 3 and 4, if I am do some simplifications here, m into del x इकडे जाईल राईट हँड साईडला, m इंटू डेल एक्स हे जर समजा इकडं राईट साईडला गेलं तर डेल एक्स बाय डेल एक्स कॅन्सल होईल इकडून, दोन्हीकडून तो पार्ट सिमिलर. आणि m जो आहे इथं डिवाइड गेला कुणाला, t बाय डिवायडेड बाय m, म्हणून इथं बघा t डिवायडेड बाय m आला इथं. आता उरलेला पार्ट d2y बाय dx स्क्वेअर ॲज इट इज टू बी देअर. So if you look at this equation is simply the equation of the string is to be there, or vibrating string is to be there. But if you compare this equation or this relationship with the your differential equation of your wave motion, and that will be, again we are aware about that, it is nothing but to be d2y by dt square is equal to v square d2y by dx square is to be there. So if I am matching this is what the differential equation for the wave motion, and this is what the first one it is, or we can say this is to be as an fifth one equation, or this is called to be as an sixth one equation. So fifth one equation is what, it is the differential equation of the particularly your vibrating string. And equation number 6 is nothing but to be, already we calculated differential equation of the your wave motion is to be there. So this is what the case where it is to be equation of the vibrating string is to be there. So in this case, using this relationship, if I compare with the 5 with the 6, I can also get the similar part in the left side. जर समजा मी 5 आणि 6 ला कंपेअर केलं तर d2y by dx dt स्क्वेअर लेफ्ट साईडला, इकडं पण लेफ्ट साईडला मला d2y by dt स्क्वेअर मिळते, आणि राईट साईडला काय d2y बाय dx स्क्वेअर, इथं पण d2y बाय dx स्क्वेअर राईट साईडला आहे. पण ह्याच्यामधला फरक जर बघताल तर इथं t बाय m आहे आणि इथं v स्क्वेअर आहे. मग ह्याच्यावरून मला velocity of the that I can also calculate regarding the string is also to be there. So this is what the case where the part you can calculate. And in this way we can see how the equation of the wave equation of the string is to be there.